Welcome everybody. This is session I don't even know what the number is. A07. What's new in the kernel with JC? And I guess we'll start now. It's about 1:10. Have fun.
All right, thanks. Hi, everyone.
Are you recording this, John?
I am not recording. Should I record?
No, I'm sorry, John Fahey. He should be.
I am John.
Sorry, just wanted to make sure.
Yep.
Thanks. So, hi, everybody. I wish I could see your faces out there, but I'm sure that you still have faces. I think we're all sick of this virtual stuff. I'm really looking forward to seeing people in person next time, hopefully. In the meantime, I hope this will work fine. I'm going to talk about what kinds of things we're planning for our next big release that are in the kernel. I'm going to talk about a couple things there, and then I'm going to do a demonstration of relatively new kernel features. It's hard to know who out there is already using 14.10 a lot and is familiar with the 14.10 features, and who is still using 12.10, hoping to upgrade soon to 14.10. So the demo will focus on 14.10 features, no new 12.10 features. We haven't really had many in a while. But you know, won't just be talking about 14.10 XE6 features. I'll be going back to XE2 and that kind of thing, just in case. But for now, let's talk about what is in our heads for vNext, which you've probably heard used as a term during this conference. It's going to be a major release probably at the end of next year or perhaps the beginning of 2023. And so, you know, we're thinking sort of ambitiously about it. But in terms of kernel features, what I want to focus on is are the constraints that customers are feeling about our limits. For instance, the maximum number of pages you can have in a table, and the maximum number of rows you can have on a page, maximum size of a chunk, that kind of thing. It's really high time we expanded those limits. It's going to be a major project, so it will preclude other sexier kernel features for vNext, but it's highly important. It's important not just for the customers who are already bumping up against these limits, but if we're going to improve our Unicode support in the future, we're going to need this as well. So that is what I'm focused on for the rest of this year and all of next year. I'm going to give you a refresher course in where these limits come from. There are 3 4-byte integers that we've used since, well, I guess the physical address is now a 6-byte structure. It used to be a 4-byte integer, but these 3 integers / structures have been used since time immemorial. And we've been kind of locked into them because we store them all over the place. The row ID, I'm sure many of you know, it's a 4-byte unsigned integer that has this format. Oops, sorry. I can't click on the page. The first 3 bytes are for page offsets, logical page numbers, and the last byte is used for slot number. We have only 1 byte for slot number, so that means there are a maximum of 255 slots on a page. When you're using 16K pages and you have small row sizes, that can be a constraint. And the maximum number of pages is now, you know, at the time when this was designed, it was deemed unlimited practically, but obviously it's quite limited now. People are having to fragment tables just to store all their data, and in some cases they can't really do that very easily. Now, fortunately, in the case of an index partition, you can have many more pages because we don't address index items based on row ID. But for data partitions, that's the maximum number of pages, whether it's 2K or 4K. Our part num, our partition number, is also a 4-byte unsigned integer. We have a nibble and a half for DB space number, and then the rest for logical page number within the partition the partition. So we can have about 1 million partition pages per space and 4,095 spaces. We don't use DB space 0, so we only get 4,095. Now those approximately 1 million partitions per space don't necessarily amount to real user partitions. If you do an in-place alter, you're going to use partition pages. If you compress a partition, that's going to use another partition page for the compression dictionary. If you are compressing blob columns in that partition, you're going to need more partition pages for the dictionaries. So it's still quite a few, but it's not necessarily 1 million tables. The biggest constraint there, I think, at the moment is the number of spaces. I don't think people need a ton more spaces than that, as long as we can make the spaces bigger. But 4,095 seems to be a little small. The physical address is probably the big one. It is 6 bytes, so you have 2 billion, and it's unfortunately it's signed. The first 4 bytes are signed. So because we use a -1 for the address to indicate a null address, basically internally. 2 billion pages amounts to 4 terabytes on 2K page size platforms and 8 terabytes on 4K page size platforms. That's seemed like an infinite amount when we switched from a 4-byte address to 6 bytes, but it's obviously not. 65,000 chunks, again, that's probably fine. It's really the size of the chunks that are the problem right now. So why not go to 8-byte integers for all these guys? Well, like I said, you've got humans are managing the spaces and the chunks and database tables, and humans don't want to be managing trillions of chunks or spaces or tables. So we don't really need to give those objects so many options there. But what we do want, what DBAs do want to always have larger is the size of a chunk, the size of a maximum size of a partition, and the number of rows per table. So it's those values that I'm focused on when increasing the size of these guys. I don't anticipate that huge pages will be a thing. I think that 64K or 128K is probably about as big a page as people are going to want for a while, as long as we can give them more slots on the page. And once you go to megabyte size pages, you're wasting a lot of space, and space efficiency will always be important in my opinion. So I'm not focused on giant pages, although we are planning to increase the page sizes in the future. So this is what I'm thinking at the moment and what I'm working on. We need to make the row ID 8 bytes. Either we're going to use a nibble and a half for the slots and give you 4,095 slots per page, or I'll give you 2 bytes and it'll be 65,000 slots per page, depending upon the page size, the maximum page size we decide on. As you can see, though, if we go with 4,000 slots per page, we get a gigantic amount of pages per partition. That's the biggest limit that we need to expand at the moment. Now, obviously, this is a huge project. We use a 4-byte row ID everywhere in our code, in every layer, including clients. So this is no small matter to just go to a larger row ID. It's going to require a lot of work, but we have to sometimes. So that's the plan. The partition number is not as critical to expand. I think we do want more spaces, although 65,000 seems kind of excessive. Again, this is something managed by people generally. And I don't think that people are clamoring for tens of thousands of spaces to be managing. They just want bigger spaces for the most part. But if we do go to a 6-byte structure for the partition number, then I'd probably go to 65,000 spaces with, again, 4 billion partitions per space. That's seems like more than anyone would ever want. As I said, not all of those partition pages are used for actual partitions. Some are used for alternate partition pages for in-place alters and for compression dictionaries and that kind of thing, but 4 billion is still way too many. So I'm considering changing the partition number, keeping it 4 bytes, but changing it to 65,000 spaces and 65,000 partition pages per space. I will do more research on whether anyone has even come close to that limit in terms of the partition size, and reconsider if people are hitting it. But that's a possible alternative. And we do store partition number. We store, you know, frag ID in indexes. So the size of that does kind of matter a little bit. If we can keep it at 4 bytes, that would be great. The physical address, though, that's the big one. Oh, first of all, the row ID and the partition number, it's possible that we'll be able to change those for legacy systems without, and do an in-place migration with your existing spaces. Once we go to a larger physical address, though, there's no hope of doing that in place. We're going to have to use a new DB space type for that. And the plan is that, you know, in the new DB space type, will allow larger pages and all kinds of other features on the page that we don't currently have. So you won't get these giant chunks in legacy spaces, legacy chunks. You'll have to be creating new spaces and new chunks to get that. But if we go to an 8-byte signed integer for the physical address, then we're looking at 39 exabytes per chunk and 1 million chunks. It's quite a bit. I know it's famous last words, but I can't imagine needing more than that. I guess we'll find out. A lot of us will probably not even be alive by the time we find out, but we'll see. So that's all I want to talk about in terms of vNext. Again, it's a big project, but that is the direction we're going in. None of that is promised, but that is definitely the direction we're going in. We are finding that customers with large instances are really chafing with some of those values, and so we have to do something about it in our next major release. Now, though, I'm going to hopefully do something kind of fun and show off a whole series of 1410 features in one fell swoop. So the first thing I'll do is, I'm assuming everybody can see these windows fine. I'm going to initialize an instance with encryption going, and I'll use a network key store. So I'll show you the credentials file, or something like the credentials file that I'm going to use for the network key store.
Hey, JC?
Yes.
Before you get away from that, I missed the chat. We have a question. Any thoughts on changing to larger default page size?
Yes. We do have a plan to default to 4K for new instances, yes. And I think that 4K will probably remain the base page size as we go forward. So I hope that answers the question. Again, for legacy systems, we're going to have to somehow support the existing 2K chunks. But by default, we will go with 4K for root DBS when you start a new instance. That is the plan.
And the response is that would only be realistic after the row ID change, correct? For data pages, that is.
they don't have to go hand in hand. I mean, if we go to 64K page size or 32K page size, then yes, there's not much point in doing that until the row ID is increased, specifically the number of slots per page. 4K, a 4K page is fine, is relatively fine with the current row ID. Once you go to more than 16K pages, which we do plan to do, then the row ID does need to change. It kind of needs to change in general, but it really needs to change then. We can survive without that change with a 4K base page size. We have for years, but we are planning to do both at the same time.
Okay, thanks. I'll try to resist, but those
okay.
seem to fit your last topic, so I'll.
Yeah, no, that's fine. I'm sure there are going to be questions that come up as I go along here. Please interrupt because unfortunately, I can't hear you or see the chat. So I'm expecting interrupts.
Okay, all right, thanks.
So this is kind of what a credentials file looks like in JSON format for AWS. We have a slightly different format for Azure and for KMIP. And you can always make a local key store file where your master key is kept locally. But in this case, I'm gonna generate and store a master key for my encryption on AWS. Now, this is not a real credentials file. Obviously, I've masked out my key ID and my secret key and my key location for obvious reasons. But I'm going to use a real credentials file to create my master key. So I'm going to use onKstore to do that. That's this new utility. OnKstore create a key store file. I'm handing you the credentials, so don't ask me for all that stuff. And I'm giving you a password in a password file. My key store file is going to be called JC Key Store, and I want it to use AES-256 for my cipher. So it has created my key store file for me, which is a P12 file, an encrypted file, and it's created a stash file with my password so that I don't have to supply a password every time I run on it or on check or anything like that. If I got rid of that stash file, then I would have to supply a password to run any utility that needs to decrypt my chunks. Let's see what my disk encryption is set to. So disk encryption needs to be set to use encryption. I've set the key store to JC Key Store. This relative path name means that that's in Informix. And I've set the cipher for AES-256. Now that's in my config file. What if I've got a syntax error there or something, or a formatting error? Well, I can double check that's correct, and that's the value that's going to be used by oninit by running oninit-t and looking for that. That's -t for test, rep for my configuration parameter, and verifying that is the, once oninit reads the config file, digests it, makes any adjustments necessary, this is the value it's going to use. And I can see that that's matching the value I intended, so that's good news. I will initialize my server. And you can see in onstat-d here that I've got an E flag next to root DBS. That means it's encrypted. There is no encryption flag for a chunk because any encryption happens at a space level. If you see an E flag at the end here for a chunk, that means it's extendable, not encrypted. This is the encrypted flag. So let's look at onstat here. 1410 has this timestamp under onstat, which is the local date and time. That's helpful when you send onstats to support, especially when they're trying to calibrate those on-stat outputs with various things happening in the online log, etc. If you hate that timestamp because you parse on-stat output and that's throwing you, then we do have an undocumented environment variable called onstat legacy that you can set, and that will get rid of the timestamp. I will unset onstat legacy because I don't want onstat legacy. So let's say that I'd like to create a storage pool. So I've got my root DBS here, but I want to create spaces, and I want to create them from a storage pool because that's a lot easier. But I can't remember what the sysadmin command syntax is. I can just go in to DB Access, select sysadmin for my database, and run execute function task usage. This is relatively new in 14.10. It'll show me all the possible commands here. I look and I see, storage pool. Well, I don't know the syntax for storage pool. So I'll run execute function task storage pool, and that will give me more. We'll be drilling down here. I can do storage pool, add, delete, purge, modify. Well, I want to add. So what's the syntax for storage pool add? I do execute function task storage pool add, and now it shows me details for that. I'm going to, what I've just done now is I've added a directory to my storage pool. It has no offset or total size because it's a directory. I've given it a minimum chunk size of 10 meg and a priority of 2. Priorities can be 1 through 3. For this entry, the priority is 2. And since I've added a directory here, when I create chunks and spaces, the system will automatically create cooked files for me in that directory, and it's very, very handy. So I've just created a space called DBS1 that's 50 megabytes, and it has a page size of 4K, and it's mirrored. I'm going to do another one, DBS2, and I didn't have to give it a path or anything. It's just very nice. This one's a slightly larger one, 100 megabytes, 4K page size, mirrored. I'll also create a plog space and a space that I will put my logical logs in. I'll add a bunch of logs to that space. I'll advance the logs, write a checkpoint, and delete the original logs. So now I have, we've got 5 10 meg logs all in this logical log DB space. Sorry, let's type -D. Here's the space that those logs are in. You can see that I've got mirroring on the spaces that I requested mirroring for. This M flag indicates mirroring. And yet, watch this. There is no such thing as the mirror configuration parameter anymore. Mirroring is now always enabled. That's new in XC7, I believe. It doesn't take any extra memory. It doesn't take any extra cycles. And it was important in order to fix a defect that was replication related. So I have enabled it permanently. Now, one thing that you need to know is if you have in your config file mirror path set to some path, in the past with mirror turned off, that made no difference. But now that mirroring is always on, if you have mirror path set to something, we're going to take it seriously. So when you upgrade to XC7, please check your config files and make sure that mirror path is not set to some random thing. The mirror path value in onconfig.std is now blank to help out a little bit. It originally was Informix temp and some file name, and we will recognize that if your mirror path is set to that, we will recognize that value and ignore it now if mirroring doesn't seem to be on. But it'd be better if you just unset it or took it out of the file altogether if you're not using it. So when in 1410, when we create a cooked chunk from scratch, we now use fallocate to expand the file. We used to do it in a fairly slow fashion. In 1210, it's not that fast. I'll demonstrate for you how fast it is now. So here is this work1 JC chunk 3 is what I'm going to use for a 20 gigabyte chunk. Right now it's 0. You can see that that chunk is not in the list. I will time how long it takes to create a 20 gigabyte chunk using that cook file. It took 17/100ths of a second. That's with fallocate. I'll show you what it would have been in 1210. You can see that that file is fully expanded. And you can see that it really is 20 gigabytes. Now I'll get rid of that space and start over again with the legacy performance, and you'll see it takes about 20 or 30 seconds. So we're back to square one. The chunk is now 0. I'm going to unset an undocumented parameter called use fallocate so that we now get the legacy behavior. And we'll see how long this takes. Now, this is off. This feature is off by default on Solaris. It's not on Windows, but it is on every other Unix platform. But it's off by default on Solaris, even though it's available there. And the reason is because there was an Oracle defect in Solaris 11.3, which seems to be fixed in later fix packs of 11.4 that caused a problem when we were using fallocate and direct.io was also being used. Vladimir wrote up a description of exactly the scenarios you should watch out for on Solaris, and it's in your machine notes. If you're on Solaris, you can just check your machine notes if you're using 1410. And if you're, if you don't match any of those criteria, then you can set use fallocate to 1 in your config file and take advantage of this feature. But for now, we've just turned it off by default just in case. So this is how long that chunk would have taken on my machine in 1210, 43 seconds. And it took less than half a second with this feature going. So that's nice when you're, especially nice if you have storage provisioning creating chunks for you on the fly. I will get rid of that dummy DB space. I'll reset use fallocate to default by setting it to nothing, basically. That will set any configuration parameter to its default. And let's do something new here. I'm going to create a database, a non-logging database. I'm going to create a round-robin table in DBS1 and DBS2. Remember, DBS1 is smaller than DBS2. And I'm deliberately creating a table that I can expand by updating it. I'm creating a dummy table that I'll use to fragment, to get more extents in DBS1 for my table. And I'm creating a dummy 2 table that will take up all of DBS2. What I'm going to do here is I'm going to create a round-robin fragmented table where one of the fragments contains rows and the other fragment does not contain any rows because it's constrained by other things in the DB space. Then I'm going to unconstrain the second fragment and update the rows in the first fragment so that they're larger and they have to migrate. In prior versions to XE6, I believe, that would have failed. But now, thanks to Jeff McMahon, it works. So here's my table. You can see that. I'll show you another thing. See this last DML time. This is relatively new. We haven't done any DML on this table yet, so we don't have a modification time here. But we will see one. I'm going to turn off auto expand and set max fill data pages and load a bunch of rows. These will all go into the first fragment. So now we can see that in our first fragment, we have 676,000 rows. In the second fragment, we have none because this guy doesn't have any room. And we can see that the last DML time was recently because that will be updated anytime you do a insert, delete, or update. We haven't inserted any rows into this guy, so that this still has no record here. And here's onCheck PE for DB space 1. You can see that we're interlacing between this table that I just loaded and a dummy table, just to give me more extents. And this extent number is somewhat new. In chronological order, it shows the extent number for each table, which is nice if you want to see what the last extent was that was created for a table. You can see I've got 7 extents here for JC tab. In DB space 2, we just have this big dummy table taking all the free space. So I'll drop that. Sorry, hang on. I've dropped that dummy 2 table, so now the fragment in DB space 2 can expand. And I'll update the table. And again, thanks to Jeff McMahon, the rows that no longer fit in the first fragment are going to be moved to the second fragment. So we have 626,000 rows in the first fragment now, and almost 50,000 of them were automatically migrated to the second fragment when they got too big for the first one. This won't happen necessarily with another fragmentation scheme, but with round robin, this will happen now. That used to give you an out of space error. Now I'm going to drop the table that was interlaced with my new table in DB space 1. Here's DB space 1. You can see I've got free spots here for this guy to expand. And in DB space 2, I've got free space as well. And you can see that I've got many more rows in the first fragment of this round robin table than the second. So I'm going to start loading into this table again. I put 100,000 rows in, and you can see that the second fragment, the one that had fewer rows in it, was completely favored over the first one. We didn't put any rows in the first one. That is new behavior. That used to only get that behavior with auto locate. You now get it by default. We want a round robin table to be balanced in terms of the number of rows. I'll insert a bunch more rows. And you can see that our second fragment has now just about caught up. And if I load 100,000 more, we'll see that now they're essentially equal. they can be off by 100. We're not going to check every time we do an insert whether, which fragment has the lowest number of rows in it, but we do batches of 100 and check, and then another batch of 100 and check. So these can be off by 100 or so, but they're going to be pretty close to one another now. So I'll show you, I'll now show you something related to IFX row ID, which is something that Art actually is familiar with intimately. So if you try to select row ID from this round robin table, obviously you'll get an error because we can't have we're not going to have row IDs on the normal row IDs on a fragmented table. But we do have this thing, this existing pseudo column called IFX_row_ID. And we have for a long time. This is the fragment ID and this is the row ID in decimal. The problem with this guy was that if you tried to select based on it, it wasn't very efficient. You would do a sequential scan of the entire table to find the data that had the IFX row ID value of this value or whatever value. So we've fixed that. Here's the IFX row ID value for the row with column 1 equal to 50,001. I'm going to prove to you that by selecting on that row ID, we're not going to be doing a sequential scan. So first I'm going to make the system really quiet. I'm going to stop the B-tree scanner. I'm going to stop the scheduler. Now I'm going to run onmode-B reset, which is an undocumented feature that it flushes all the dirty buffers and invalidates them. So I have no more buffer pool, even though my buffer pool seems to have, it's still there. None of the buffers in there are considered valid. So as soon as I want to read a page, I'm going to have to go to disk for it, which is nice for internal people who want to test various things and something you wouldn't necessarily use. But anyway, I'm going to force disk reads by running onmode-B reset. I'm going to zero out my statistics. So you can see we've got a very quiet system. I've got nothing going on here. And I will select from this rather large table where Informix row ID is this. And now if I check my statistics, I got one disk read, and I read the same page twice, basically. So clearly I'm not doing a sequential scan there. If you tried the same kind of trick in an earlier version, you would have thousands of pages read there from disk. So I'll be curious to know whether anyone, I've described this improvement since the spring. It actually came in the spring. And I'm curious whether anyone has made use of it yet. You can tell me later if you want. I guess Art has. Thank you. I'm glad. I never hear about these things. I just put these things out there and nobody says anything. So it's always nice to hear. Here's an improvement to message date. In the online log, you can see our timestamp is just hour, minute, second. It's just a kind of a fixed format there. If we, so this is coming from the message date configuration parameter, which is set to 0. But if I run on stat-g CFG full message date, you can see all the possibilities here. This is the legacy format. If I set it to 1, I'm going to get a month, day, year, and then a timestamp format with the month and the day locale dependent. 2, value of 2 will give me milliseconds since the epoch, plus all that, again, locale dependent. And 3 will just be a kind of a fixed format, 4-digit year, month, day, hour, minute, seconds, fractions of seconds. So let's take a look at that. I'm going to set this on the fly to 1, and you can look. Fortunately, we get a little message in the log anytime we change a parameter, so you can see the format nicely there. That would be, it would be 610 if I were using a European locale or whatever. So here's number 2, milliseconds since the epoch. I'm not going to ask who is needing or using that. We got a request for it, so we gave it to you. And here is number 3, 4-digit year. Unfortunately, this is not locale dependent, time and fraction of a second. I will now set message date to its default by setting it to 0, setting it to nothing. Let's look at query timeout. Standard date time. So this query timeout is relatively new. I can set it to 20 seconds and run a query that's going to take a long time, a correlated, some crazy query that nobody would ever run. And while it's running, you can see this is the select statement that this session is running. You can see the query timeout setting. You can see the clock time elapsed at that moment. And eventually this thing timed out because I gave it a timeout of 20 seconds. And you get a 213.157 error. Statement timed out or was interrupted by a user. That's a new message, the timed out part. So that's somewhat helpful, hopefully. I don't know if anyone's been using that so far. I'm going to do another reset of my buffer pool. I'm going to run onstat-g top 10.10.2, which means 10, it's going to give me a sampler of onstat-g top 10 of various things, 10-second interval. That's going to give me 2 of them, 2 intervals. Meanwhile, in the background, I'll run a script that, oops. Let me try that again. I'll run a script that does a bunch of deletes and inserts and deletes and inserts and just churns away here. Let's see what onstat-g top says. So here's our first 10-second interval. We can see that my SQL exec thread is eating up most of the CPU time. This is the top threads for CPU usage. Top memory pools for growth. Top partitions for disk reads. Top DB spaces for IOs. Top threads for physical log usage. And there wasn't any logical log activity to display. This is a non-log database, so it's not that surprising. But obviously we're doing a fair amount of physical logging since we're deleting from a non-log table. So that's just onstat-g top, which tries to guess what the most important attributes are to show you. In our second interval, you can see there wasn't much happening not because I wasn't stressing the server, but because there wasn't, well, in terms of the disk reads, we had already seeded our buffer pool, so we didn't have any disk reads. Let's try another couple here. I'll do top chunk average write times. And
Bearer of bad news, 5-minute warning.
yep, okay. I'm just going to keep going till we run out of time, I guess. Or if you want, you know where to find me if you have questions. So I'm just going to keep going till we run out of time. Here, I will. I'll ensure I get some disk reads. So if you suspect you have a slow chunk, this would be quite helpful for that. It shows you, the top chunks in terms of average write times, the worst ones at the top. I'm using a machine that's pretty fast, so I'm just not getting that much going here. Let's try memory pool growth. So I think we're going to see a memory pool here growing that is related to encryption. So far, we're just seeing my sessions memory pool. I'm surprised we're not seeing it yet. But anyway, if we or you suspect some kind of a memory leak, this would be very helpful there. You can see the total size, and so each time it pops up, you can see whether it's really growing or if it's growing and shrinking and growing and shrinking. I don't have a lot going on here to show, but obviously that onstat-g top is helpful for real systems that are under a lot of stress. I'll see if I can show you one more thing. One more quick thing before we go. Here is a little feature that was requested by Cisco. So I've got a log database and a logging table. And in this table, and it's got an index on it. It's got 10,000 rows. I'm going to say begin lock table in exclusive mode. So a normal on check will bomb out with a lock error. File is locked. But as of XT7, you can say -W for wait for locks. I can wait for a certain amount of time. So I'll wait for 10 seconds in this case. And I won't unlock the table here. We'll see a timeout. So the timeout expired. Let's try that again. And this time I will unlock the table by committing. And the on check continues. So you can wait indefinitely with just -W, or you can wait for a specific amount of time with -W seconds. It looks like we're at the top of the hour. That demo took longer than I expected. Sorry about that. There were other things to show you, but anyway.
Do you see Mark's question? Does -W by itself still ignore / skip pages that are locked?
No. In the case of if you have row level locking, we don't need a share lock on an index in order to check that index. That's something we've had for a while. But in terms of actually running into a lock, we will not skip pages that are locked. We will wait on the lock with -W.
The meeting does not go away automatically at 2. We're just cutting the time in between your session and whatever the next one is for everybody who wants to go. On here, it's Dave's doing security highlights.
Yeah, so
Go on until it cuts us off.
we, you know, one of the things we did in the kernel, security is considered kernel, and one of the things we did was we now support TLS 1.3, and that's new in XE6, and I think Dave is going to mention that in his talk. If you're interested in security improvements over the last, I mean, who isn't? Then you should go to Dave's talk. He's going to talk about security enhancements and, among other things, TLS in the next hour. I guess if anybody has another question, I can try to take one before we finish. Are we going to be able to restart? Sorry. Did you catch that, John?
Be able to restart an SSL listener.
An SSL listener. That might be a question for Dave. I do not know.
Anybody else? This is being recorded, so you can go back and watch it again. And actually, I will do my best to save the chat in case anybody put some questions in there that you didn't address that they didn't see.
A lot of you know my email address. You can always come to me with a question.
Probably far too many of us.
I don't mind questions. All right, well, why don't we close it out and give everybody a break?
All right. Thanks, JC. Thanks, y'all.
Thanks, everyone.
The recording will be available, I think, starting tomorrow. I forget exactly. If you have questions about it, email conference@iiug.org.
Thanks to all. Have more fun at the conference.
Thanks, JC.
Thank you,
See ya.
JC.
See ya.